Okay, we'll start. So today we're gonna go over the solution from yesterday for Valid Palindrome. I think the time complexity was O of n plus r. And we can double check that, but space complexity was also O of n, but the suggested was O of 1 for space and O of n for time. So today we'll try to optimize for that solution, and then I'll give myself some time. So I'll actually time it, unlike the past couple of days where I've just been taking as much time as I've wanted to. This time I'll time it just so I could try to get to a different problem. And if I can't optimize it, let's say within 20 minutes, we'll just look at the solution and we'll move from there. It's already solved, so there's no reason to submit again. I just kind of want to see if I could come up with the time complexity that they recommend. Yeah. So this is what I had yesterday, where I had a string and I iterated through the parameter s and removed all non-alphanumeric characters. Essentially, SS, which is the copy of S, has all the letters lowercase, and it has no spaces or special characters. Once that was done, I made two pointers, I and j, and I moved them towards each other as long as they were equal. Yeah, so as long as the characters were equal, I will increment I, which is the left pointer, and then decrement j, the right pointer. Otherwise, I would just return false. So if they were not equal, then it's not a palindrome, so we could just return. Once we've processed all of the letters, so when the pointer I becomes not less than j, we've essentially processed all of the letters, and then we can just return true. Let's see, submissions. I've tried to do this before, and you can see this is when I was writing Java. That's what they were teaching in school, and so I was doing a lot of the work in Java back then. Now they taught us C, so now I'm doing everything in C or C++. So when we look at this, we can't analyze because we don't have the pro version. I'm wondering if I can use the Leetcode. I think, does Leetcode analyze your time complexity for free, or do you have to pay? Leetcode Valid Palindrome. Okay, and so we're just, oh, this is Leetcode. And I'm just gonna paste this over there. This is the solution from yesterday. Perfect. And just submit it. Did I do the work in Leetcode? I feel like Leetcode has more people. I don't really care about the ranking, but I like that it's been more consistent for years. Okay, so what does this say? It says I have one analysis left. I'm guessing. Wait, maybe it is optimized. Okay, let's just use this. So it's not free, but I have one more. Okay, I don't care about that. Am I too zoomed in? What's going on here? Wait a minute. Yeah, let's see, code style. I cannot read this. What's going on? Like overlapping. If I refresh, this is gonna be better. It says something underneath there. So it says we're O of n. So I don't know why yesterday ChatGPT was like O of n plus R. The only thing is it takes more space. It says try using 2 pointers directly on the original string. I feel like that is possible. Since I said we're gonna give myself 20 minutes, I'm gonna go back and try to do that. So let's see. We're gonna do a quick whiteboard. We're gonna do a timer. We're gonna do, that's too much time. Can I do 10 minutes whiteboard? That may be too much, but let's do that. I'm gonna put 10 minutes on here and we're gonna whiteboard. If the whiteboard works. That's not the whiteboard. There you go. Okay. So we're gonna try to remove the overhead, which is SS. And we'll do this by just adding conditional statements to the pointers. Let's see. There's a time crunch here. me grab this word. Perfect. Okay, so we'll have pointer here, call this I, pointer here, we'll call it J. Let's see. So we could say if I or J we can't group them actually. We have to say if I is not alphanumeric, then we can increment. Else if I not equal to J, then we return false. I think that makes sense. And then we'll do the same for J. But instead of incrementing, we decrement. So we'll do J minus minus. But the conditional is different. So if J is not alphanumeric, then we decrement. I think that's it. Let's go back. So we'll go back to Leetcode. Because we have 5 minutes. Let's do it in Leetcode actually, since they gave us the hint. This okay, so we are just going to comment this part out. I'm not gonna make a copy. Okay, so we will say, I think we still use this. So let's grab letter. We'll call this left letter. Yeah, so we don't have to do this. We could just say I. Here we could just say J. The left letter is, okay, wait. No. I think I'm misunderstanding here. Okay, I was just copying the same thing. I don't know what I was thinking. Should have read it. Right, so we grab the left letter and the right letter. And we first check, I'm going to remove this and look a little different. We first check if the letter is alphanumeric. So if left letter, if it's true, we want the opposite actually. If it's not true, then we can increment I, else if wait, give me a second. We should do the right pointer. So we want to do the same as above, but for the right. Something like that. Yeah, so if the left pointer is looking at, let's say, a special character, we increment it. And if our right pointer is looking at a special character, we decrement J. Okay. And then the final else if checks whether they're equal. Yeah, left. And we should just do if they're not equal, actually. So if they're equal, we don't do anything. Wait. Sorry. If they're equal, we move I up by 1 and J down by 1. Else, we return false. Think. So for example, let's say that the left pointer is looking at a space. So it's going to increase I. Yeah, we just increase I. And we check that the two pointers are not equal. We have 3 minutes. Okay, we get to the end. Okay, we return true, that's fine. It should just be size -1. Okay, it failed this one. So I have an idea. I am going to, I'm gonna grab this whole thing and we're gonna go to terminal. And we're just gonna add it as another method. We can delete this. We will call this I'm going to call it optimal. And we'll run the debugger to see what's going on. So let's take a look. Okay, let's replace this with V. Is V palindrome? That's true. Which one should not be a palindrome? It should be T. We'll replace this T. The naming is a little confusing, but I think it should give us the right thing here. Okay, and then actually, I think that one did pass. Race car. They don't even have that one here. Can we add our own case? Test cases? Oh, perfect. Let's add this one. Okay, it passes that one, so that one's not a good one. Why is it failing this one? Oh, is it case? It's the case sensitive thing, right? I think that's the reason. Let's see, okay, these are all lowercase, of course. Yeah, it might be the case sensitive thing. We out of time? We have 2 minutes. Okay, let's go back. So we can turn the letter to lowercase. So we should do that before comparing them. Probably the best idea. So we'll grab this. See. Actually, we were doing it here, right? So let's see. So this is fine. We don't have to do anything there. I think it's here. So we have to turn the letter into lowercase. I think that's it. For the test case. I think that's it for the test case. Is that too much work for him? Should we do it up here? What am I missing? Probably not closing. This is like horrible to look at. What is happening here? Oh, wait a minute. Okay. Left letter. I have to close it here, right? You have to close it here. Oh, look at that. I'm missing one. I think that was it. I mean, we're not using any extra space. Did we do it on time? A minute to spare. I swear this was free, not the bot, not the chat bot. I swear this was free. Beat 100%. That's funny. Okay. Yeah, we're doing all this on the original parameter. So objective complete, we've optimized. Oh, let's fix it also on the terminal because I'm saving these files. See. So essentially what we did was we turned them into lowercase. I'm not going to type this out. I'm just going to copy it. Isn't that just nice to look at? See? Yeah, that should be fine. I'm not going to run it here because, well, we've already proven that it's the right solution. So let's move on. The next question. Let me update my notes too. Give me 1 second. My 13th stream. Let's see. It's another question. Did I do this one? These I have not done. Or maybe I have. Let's look at submissions. Oh, it looks like I have. Okay. Over a year ago. So fair enough to say I haven't done it. So we'll do this one. I'm gonna write this down. 2 integer sum 2. I don't have it in my notes. Very interesting. Okay, what does it say? Okay, you're given an integer array. It's sorted. So in non-decreasing order. Okay, couldn't they just have said in increasing order? Anyways. So return the indices of two numbers such that they add up to a given target number. This time I think this time the indices have to be in order. But the indices cannot be equal. We can't use the same element twice to sum to our target. It will always be exactly one valid solution. Solution must be of 1 additional space. Okay, so we can't take extra space. I'll disregard that for now. Let's see. The examples has 1 through 4, target 3. So should be index 1, or sorry, index 0 and 1. Okay, let's look at the topics. 2-pointer, binary search. Isn't the binary search where you start halfway in your array or something like that, and then determine if the halfway point puts you out of range? So for example, let's say that, how can we do this? Yeah, let's say that we have 2 pointers. One of them starts at the beginning of the array, so index 0. And then the second pointer starts in the middle of the array. Then we can do the sum of those values and compare it to our target. And then if that sum is greater than the target, then we shift the pointers to the opposite side. So we can do, oh, actually, I don't know. No, wait. So I think I'm thinking about this right, but we don't shift the pointers. What we do, if the sum of the 2 pointers is greater than the target, we know that any value to the right of our rightmost pointer can be disregarded. So we can discard it, and so we don't have to move the right pointer up anymore. We can move it down. The question then becomes, so we move it by halves, I think. Let's whiteboard this. Let's take the example. That's not what I meant. I should put a timer for this. Let me go do that. Okay, for whiteboarding, I'm gonna give myself maybe 15 minutes. That might be too long. We'll start there. Yeah, we could. Let's just scratch this out for now. It'll be relevant. Okay, this is what I was thinking. I think this is fine. Made it a little longer. So we'll start with I here. Then J would be here. Okay, then we take their sum. We have 4, which is greater than our target. So we can move J down by 1. Let's make the target something else. Shouldn't have taken these off. Okay. We'll group this. This is all one thing. Okay, so we'll start there. But let's make our target 5. Yeah, let's make our target 5. Okay, so the sum is 4, which is smaller than our target. Let's say 5 is our target. That's our target, 5. Okay. Unless I'm doing this wrong. Am I doing this wrong? I think I might be doing this wrong. Is that not how you do binary search? So who do we move in this case? Let's change targets. Maybe I should look at a binary search thing, like a video or something. Take a look. It's my video from yesterday. Okay, the only problem with that is the target is not a single value, it's the sum of two values. So what do we start from the middle, we split the array in twos, then we check subarrays. I don't quite understand, when do we split again? I wasn't showing the video. Okay. So what I'm thinking is, say this is there's gonna be the box that represents the area we're focusing on. Okay, so initially we'll be focusing on the first half of the array, and I'm trying to see. Yeah, so okay, this is what I'm thinking. See if I can draw it out instead of writing code. Okay. So I'm thinking about this in like a number line. And And then what we can do is we can move a pointer to the middle, which will put us here at 3. Yeah, so we'll be here. And then to figure out if we're gonna eliminate the left side or the right side, we can do the sum of the values next to it. So for example, here we'll get 5. Here we'll get 6. 7, sorry. Okay. And then these two values, we can, okay, these two values represent the highest. No, this is wrong. What's the time complexity on this? Just use a table. Oh man. Okay. The table would take O of n though, in space. Not optimal. Can we do, okay, we'll take 1. We'll take the difference from the target. And then we'll do binary search for that value. For that value, but in this index, within these indices. So we can never go back. I feel like this is more complicated. This doesn't seem O-Ven. Because then to search for 5, do we have to implement binary search, or is it like a library? Because then you'll look for 5 here. It's an increasing order, so then it could discard everything to its left, including itself, because itself was not 5. You could split the subarray, take the lower end. 5 is our it's the difference that we're looking for. So then we could grab its index, which is 5, 4, I think it is. Yeah. And then the index from the original is 0. Let's see. Let's say let's keep that there. Say the target was something else. Let's say the target was 9. So same as before. So this should be 9. And this is where we're starting. We're going from left to right. So we'll be looking for 8 in the blue region. We can do binary search. It won't find it. So if it doesn't find it, we can move. Let's call this I. We can move I by 1. So then this would change, right? To 7. And it'll do binary search on these values. Okay, that won't work either. Okay, 6. It would find 6. That seems to work. I think that doesn't seem like O event to me though. Because we're doing a for loop through the original array, and then we're performing binary search on a subarray. So would that make it like n plus m? I think. See. Let's try to do it this way, and then we'll go back to the recommended. We'll try to optimize. Also, our timer's up. So that was 15 to 20 for solving. Let me just save this. Make a new file. We'll call it actually cancel that. Okay, wait, we need to know. We need to store anything. Oh, the resulting vector. Just sets them to 0. Then we can do a for loop that goes through all of the numbers starting at 0. So let's see, int. What is that called? It's not called difference, it's called something. Yeah, we'll just call it difference. I think that's the right word too. They use something else. I've seen it on the other problem. So we'll do difference is going to be equal to current index number minus, actually is a target. So target minus a number. Okay, now we want to perform binary search on a subarray. And I'm not quite sure how to do that. So we're gonna go to the web. Okay, I'm not too sure what happened with the stream. Is there like a library for it though? This is not good. Okay, so the solution is more like n log n, not n log m. Okay, let's just continue. CC returns last if the element's not found. What does it mean by that? What is lower? Oh, it's that one. Okay, so we have to check that it's not the end of our array or our vector, because and would indicate that the value I was not found within the range. We won't want to do begin 0.2. We would want to do the index we're at +1. So let's go back here. Actually, wrong one. What's that? I'm going to take this. I'm just going to take the whole thing. Might as well take this too. Let's just take this one. Okay, so that does the binary search for us. We have to modify it a little bit. So the beginning is going to be from I +1. And we're looking for the difference. Wait, I thought lower bound returned the index. Does it not? Oh, so we want to use that. Okay, I'm gonna take a break. See. and I'll be back. Okay. So I was trying to figure out how to use this lower bound method. I don't quite understand how to what parameters I need to pass. This is what I was looking at right here. So search after skipping index. So skip is the index we're on plus 1. I think this is what we want to do. I'm going to take this. I could just go back and look at it. Let's see. So it's going to be begin plus the index I plus 1. What does it return though? I need the index. I don't need some true or false statement. Okay, the first element that's greater than or equal to. That's why they do the comparison to the target. So if it's not the and it's equal to the target, Wait, I want to see what this looks like in Python. Is that why people use Python? Anyways. Okay, so lower returns an index or the end of the vector. So in the condition that it's not the end of the vector nums and that it's equal to the target, and actually it doesn't want, it has to be equal to the difference, not target. Because that's the one we want to pick out. So if it's equal to the difference, then we convert it to its index. Right, and then we just do that for every number. We can also do this. So this is in the condition that both of the numbers that sum to the target do exist in the vector. Just because we don't find a difference in the numbers vector does not mean that there's no solution. The only way we know that there's no solution is if we've essentially processed all the numbers and the results vector is still empty. So I guess we could do so we could say if res dot empty return false. Oh, that's not it. We just return the result, which is an empty vector. Else we just else we return result. Wait, we're not returning the index? Wait, what? Wait, index 1 and 2? What am I missing here? Let's see the example. Why are we using a one index array? There. Piss me off. Why would you use a one index array? Okay, I don't get that. Wait, I don't care about that right now. Why would they do one index arrays? I think it's perfectly fine with starting indexes with 0. What's wrong with these people? Oh, so do we just do... Okay. Well, we could just do it here. We push the index plus 1. Okay, when did I type R? What do we get now? We changed this to 1 earlier. Okay, again, not optimal. We're going 2 for 2 now. Yesterday's was also not optimal. Okay. I think non-optimals are the best. Let's see. This is the binary search. Lower bound. I don't quite understand. Okay, my understanding was that it returned the index. So why do we have to convert it? Let's ask chat. Okay, it does not return an integer index. It returns an iterator. Let's see. The example is if you have this vector, lower bound target 11 would succeed. So then lower points to the element 11, not the number 2, which is its index. We can grab the value, but we can't grab the index. And the position infinity must subtract the beginning iterator. The distance from the start to the position where the value is found. Wait, what? Interesting. So they did the binary search, but then instantly converted into an index. They just subtract beginning. That's much nicer. Wait a minute. So if lower bound doesn't find the target, wouldn't that break? I cannot spell. Okay, that's not good. Okay, so if the index is less than the size of the vector and the specific value of that index is equal to our target x, and we found the value. Okay. I think I ran this right. Let's see. Oh yeah, it's on there. I think we could just play around with this a little bit. So we should make a vector nums. Okay, then what? Actually, I have a better idea. I'm going to fill it up with super large values. Actually, let's just leave it here. Should we do another one? I think that should be good for today. Let's see. Well, it's not optimal. Let's think a little bit on how to optimize it. Let's look at the hints. What is n? Okay, one at the start, one at the end. If the sum of the numbers that was it. Okay, we'll try to do that one tomorrow. Yeah, this is a perfect description. I think these are the solution, brute force, binary search, wait, let's see. The complement, not the difference. That's the word I was thinking about last time. Cool. Okay, we'll stop there. We'll try to, I don't know if it's worth it trying to optimize it now that I've just seen the solution. Probably not, but we can come back to it later at a different time when my memory of the solution on this problem is a little bit more hazy. be worth trying to recall that solution that we just seen. Okay. I think that's all for today though.